Okay, so this short video is going to take you through finding machine learning examples in Apache Spark, and we'll also see some files showing the appropriate data format. So we'll start off in the usual way. We've got the container on our screen here, which wants the usual password, which you'll find in the show notes, and we'll enter our password. And as you can see, we've got the usual working directory up there ready to show notebooks. But I'm not going to use the notebooks. I'm going to instead start a terminal session. So this is a terminal which is running inside your web browser and which is connected through to the container. And this is I'm going to show you where the system files are for Spark, and they include user examples. So if you've used the usual Unix prompt, that's what we've got here. Generally, I use the bash shell interpreter. That's got some useful features, such as the one I principally want today, which is completing file names using the tab key. So if I start typing a folder, hit the tab key, it will complete the file name. So that's a very handy tip. And if I just use pwd to see the directory in, you can see we're in home notebook user, which you will have mapped when we started the container to some local folder usually. We can also use upload and download from the main Jupyter page as well if we want to bring stuff up. Now what the Spark installation is in slash, so I'm going to list the folder, so that's what ls-l is, /user local, and if I hit the tab and there's more than one choice, then the bash shell will complete the options, and you can see we've got Spark on there. And if we get Spark, that's our folder name. This is why using the tab key is quite handy, because we've got Spark 312, etc., etc. So you don't need to be typing that. You should just be able to hit the tab key. And we've got various folders underneath here. Particularly what we'll be looking at are the examples folder. So I'm going to so I've just used Control A there to go to the start of the line, and I'm going to do CD to change directory, hit the tab key again, Control E, go to the end, and what we want are the examples. And if you look inside examples, we've got jars, which are obviously Java libraries, and source, src. So we hit source, and what we can see is we've got examples for Java, Python, and R. We're using Python in this module, so I'll hit Python. I'm changing into this folder. And now you'll notice at this point that the bash prompt by default is showing us the whole path name. And that's not, well, it's very handy until the point where we've only got this small amount of space on the end. So I'm just going to change the prompt to just show the username. That's what that command there does, which is a bash command. Now we've got a bit of space. We can still see the folder by doing pwd. We're in Python. I'll do list the folder again, and you'll see we've got several standard Python files with the .py. All these examples are designed to be quite short. They're not notebooks, they're Python files. And we've got two choices for machine learning. We've got ML and MLlib. MLlib is the older format, which is using RDDs. And the up-to-date version, the MLlibs are still maintained, they still work, but the version which is more common now and which is being promoted is the ML library. So if I do CD into the ML library, ls-l again, And you can see we've got a whole bunch of machine learning algorithms, only a very small fraction of which we will use on this module. And they do, let's see, some standard kind of things which you've probably met already: logistic regression, linear regression, latent Dirichlet allocation, or whatever, k-means. These are standard things. Somehow around here we will have a support vector machines example. Anyway, you'll find all of these fully documented elsewhere. Let's take a basic machine learning example such as naive Bayes, and I can just show this. I don't know, that will do it. Let's try this one. Naive Bayes. Again, I'm hitting the tab key to complete. And you can see that very nicely fits onto one page, so that's quite handy. And you can see they've imported the PySpark ML library example. This is where the algorithms are defined. Start a Spark session in the usual way, and you'll see it reads data format in the libsvm format. You can look where this is online, but basically this is a sparse data format. So you'll notice that the data file, which is read here where we've got this Spark read format libsvm, is looking for something, a data folder relative to this folder where this example is. But in fact, we saw earlier that the data was at the top level. So what we're going to do, so you can work on this example, is copy this file into a local working directory, copy the data as well, and then we'll see if we can run it. So to do that, first thing we're going to do is we're going to just make a directory. So if I do mkdir, our home directory is shown with the tilde squiggle sign, and we have a working folder. Let's make a directory called Python. Now we want to just copy, that is CP, this naive Bayes example into /working Python. So I'm just typing 2 letters, hitting the tab key. That's copied that. Now we want to get the data file, and the one we're looking for is called sample libsvm_data.text. And we're looking for the data folder, as I said. And that is quite a way up, because remember we came into the Python subdirectory, and those are the examples. And in fact, I remember at the same top level as the examples, we had a data folder. So that is 2 dots up. So if I now do cd data, ls-l, mllib, so it's actually in mllib. That's right. So mllib corresponds to what we got there. ls-l. So this just shows us all the data files that are used for all the examples, actually. So these aren't big data. The point is to demonstrate the machine learning algorithms and the data file formats. And the one we're looking for is down here, sample libsvm data. And as I said, or possibly didn't, SVM, support vector machines, has got a well-known sparse format. Sparse format means it doesn't show all the columns and all the values. It only shows columns which have values and the values in them. So if we just have a little look at that. So have a quick look at the sample libsvm data. This is a very well-known file format, and you'll have to look into this a bit yourself, but I will just run through it so you can see what to expect. As with almost all machine learning, we're looking for rectangular data sets. That's what we process. And this is no exception. Everything is numeric. So basically when we have text data, we use various tricks to convert that into a numeric data. But in this case, it is purely numeric. The first column here, 0, means these numbers don't correspond to the classification. The rows that begin with 1 do. And we've got values, and then we've got the columns. So that's the way this works approximately. So we want that data file in our home folder. So let's go right ahead and copy this into working Python. So that's going to now be in the same folder as our original example. And in fact, if we now cd into /working Python, we should see both of these. As I said, these are Python files. We can do two things: either run Python, which will import PySpark and work that way, or we could take the example apart, put it into our Jupyter notebook and work like that. We will have to make a little change because when we look at this file, remember it's looking for this data file in this subdirectory, and that doesn't exist. So we need to just edit this. You can either edit it by mapping the file into local editor. There is an inbuilt editor inside the container, which is Nano. And so we can use that. Let's go ahead and have a go at that and then get back. Well, I'll pause this a second. Well, let's just... So we just used the Nano editor. I'll just go through that with you. Very simple, straightforward editors working in text mode here because we're running in the console. So we can just go right ahead and just use the regular controls. So I'm just going to delete the folder. Should be looking for this in the home folder, and we should be able to write this file out somewhere, which is Control O, and file to write, yes, and then you do Control X to edit. So this example should now be runnable. I'm going to pause again, just check that that's the case before running through. So just to keep things simple, I'm going to run this in the terminal. We don't usually do that. We want to see the results of things, but in this case, we expect the example should work. So just Python and the name of the file. And we get the usual messages and warning messages and so on. And then we get a table of results, which we were hoping to see. We can see the probabilities of the various classifications and so on for this particular sample data set. So just to sum up, what we've done is we've found the machine learning examples, which are in the user local Spark, and then you have to navigate through to the examples. We found the data, we copied them into a local folder, we've run those, and the same procedure can be applied to any of the examples you're looking at. Full documentation of the examples will be found in the Spark online Spark documentation, and these examples are also discussed in the or at least the techniques are discussed to some extent in the Learning Spark book, which is our primary source of information. So I'll stop there. Thanks.